This is guided practice 1.2. Let's look at the first one. Directions, we always want to make sure we know what it's asking for. Write a ratio as a fraction in simplest forms, and then explain its meaning. Okay, so what we have here is we have pens to pencils. So it's going to be pens to pencils, or if we're writing it in a fraction, pens, pencils. You always got to look what it's asking for first. Whatever it's asking for first goes on top, the numerator, and what it's asking for second goes on the bottom, the denominator. Pens to pencils. Okay, so let's do pens. 1, 2, 3, 4, 5, 6. 6 pence for every 1, 2, 3, 4, 5, 6, 7, 8. For every 8 pencils. Now I look at that, 6 to 8. I know that's not in the simplest form. So I'm going to find the greatest common factor of those two and then divide it by that. So I take the smaller number, 1, 6, 2, 3. Does 6 go into 8? Nope. Does 3 go into 8? Nope. Does 2? Yep. Okay. So I can divide each by 2. This becomes 3/4. So the fraction in simplest form is 3/4. So for every 3 pens, there's 4 pencils. All right, let's look over here. We have pennies to dimes. So pennies goes on top. 1, 2, 3 pennies to dimes. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 dimes. So again, I want to see if it can be reduced. I'll do my 1 and 3. There's my fraction rainbow. Does 3 go into 9? It does. So I can divide each by 3. Divide each by 3. That gets me 1/3. 1/3. So for every 1 penny, there's 3 dimes. Okay. Let's look at number 3. Last month, add 8. 9 apples, 5 bananas, 4 peaches, and 7 oranges. Find the ratio of bananas to the total number of fruit. Okay, so bananas, that one's going to go on top. That to total fruit. Total fruit is going to add up 9, 5, 4, and 7. So if I do 9 and 5, that's 14. 4 and 7 is 11. And together, that is 25. 25 total fruit. So bananas to fruit is 5 to 25. I want to find my greatest common factor. Does 5 go into 25? Yep. So I divide each side by 5. That gets me 1/5. So for every 1 banana he ate 5 pieces of total fruit. Okay. Let's go down here a little bit. Number 4. Divide 28 cans of soda into 2 groups so the ratio is 3 to 4. Okay, so we have 28 total cans. We want it to be 3 to 4. So it's going to be some number over some number, but this is going to equal 28. Okay? So we have 3 groups here to 4 groups. Okay? And each of those squares has to be the exact same number. So I have 1, 2, 3, 4, 5, 6, 7. I'm going to do 28 divided by 7. That gets me 4 in each group. So this is going to be 4, 4, 4, 4, 4, 4, 4. All right, now my fraction, here's 3 groups over 4 groups. That would be 12 over 16. And 12 plus 16 is 28, which is how many cans of soda we have. We divided them into 2 groups. The ratio equals 3/4, if you would simplify it. Okay? Cool. It's a little bit tricky. But if you do it into a diagram or a bar graph like this, it makes it so much easier. All right, number 5. How can you use mental math to determine if a ratio is simplified? For me, if you look at the number, the 2 numbers, and you figure out the greatest common factor, and if the greatest common factor of both of the numbers equals 1, then it is simplified, okay? Because anything divided by 1 is itself, and it doesn't get any simpler than that. So if you do the greatest common factor, you see that they're both 1, or that the greatest common factor is 1, you know you are in the simplest form. Alrighty. Okay, go ahead and do the independent practice on page 23. Do numbers 1 through 6. So I want you to do those, try them, and then watch the videos to check and see how you did. All right?